Welcome back everyone. In the last lecture, we have discussed in detail about the primary processing and secondary processing of herbal raw materials. And in this lecture, we are going to discuss in detail about different extraction methods which is used for the preparation of fruit drugs from herbal raw materials. Extraction. It is nothing but the method which is used to remove active constituents from a solid or liquid by means of a liquid solvent. In this, the separation of medicinally active portions of the plant or animal tissues from the inactive or inert components can be done by using selective solvents. So, in extraction methods, the wanted components are dissolved by the use of selective solvents. They are known as menstruum and the undissolved part is known as mark. After the extraction, unwanted matter will remove. Extracts are prepared by using ethanol or other suitable solvent. So what is extract? It is nothing but the preparations of crude drugs which contain all the constituents which are soluble in the solvent. That is known as extract. Then mark. It is a solid residue obtained after extraction and menstruum is nothing but the solvent which is used for extraction. And there are different types of extract having used to extract phytoconstituents or separate phytoconstituents from the herbs. So some of the examples are dry extract, soft and liquid. Liquid form is using as a tincture. Mechanism of extraction. It is nothing but the extraction of phytoconstituents from the particular plant cell. In the first figure, we can see that the plant cell which is to separate the phytoconstituents is put inside a particular solvent. And in second figure, we can see that there is a reaction occur between the plant cell and the solvent. And the third figure, we can see that the particular phytoconstituents which are present inside the plant cell start to interact with the solvent and which is to separate inside that solvent. So there are some factors which affect the extraction processes. So these are the factors that is nature of drug, solvent, temperature, pH and particle size. Already I told that different methods are there to extract phytoconstituents from herbal plants. So they are infusion, decoction, digestion, maceration, percolation, continuous hot extraction, superficial fluid extraction, countercurrent extraction, microwave assisted extraction, ultrasonication assisted extraction. So first one is decoction. So in this process, the crude drug is boiled in a specified volume of water for a particular time period. Then it is cooled down and strained or filtered. This procedure is suitable for extracting water-soluble or heat-soluble constituents. Example, tea or coffee. Another method is infusion. So fresh infusions are prepared by macerating the crude drug for a short period of time with cold or boiling water. These are dilute solutions of readily soluble constituents of crude drugs. So different types of infusions is there. Fresh infusion and concentrated infusion. Infusion of orange is an example of for fresh infusion and concentrated infusions of quassia is an example for concentrated one. Next one is digestion. It is a form of maceration in which gentle heat is used during the process of extraction. It is used when moderately elevated temperature is not objectable. The solvent efficiency of the menstruum is thereby increased. Example, morphine extraction can be done through this digestion process. Maceration, it is nothing but solid ingredients are placed in a stoppered container with the whole of the solvent and allowed to stand for a period of at least 3 days with frequent agitation until the soluble matter is dissolved. The mixture is then strained, the made pressed and the combined liquids clarified or by decantation after standing. This flow chart shows the process of maceration. First step is the collection of plant material and the collected plant material should be crushed or cut into small pieces or can use it as in powdered form. Then the collected plant material should be placed in a closed vessel and add selected solvent which is known as menstruum. Then allow to stand for 7 days and shake occasionally. Then after 7 days or after the time period, liquid strained off from that vessel, solid residue pressed and stained and exposed liquid mixed, clarified by subsidence or filtration. The final step is the evaporation and concentration of the separated components. Types of maceration. There are 3 types of maceration: simple maceration, double maceration, triple maceration. Simple maceration which is using for organized and unorganized crude drug. Example, tincture of orange, lemon, squill. Double maceration, it is used for concentrated infusions. Triple maceration, it is a process may be carried out with the help of heat or stirring. Example, concentrated infusion of senna. So these methods which also have some merits and demerits. Merits are small sample size, strong spelling properties or high mucilage, energy saving process. The demerits are not exhaustively extract the drug, very slow process, solvent required is more. These are the different steps which is used in the process of percolation. First step is size reduction. The drug to be extracted subjected to suitable degree of size reduction. It may be from coarse powder to fine powder. Second step is imbibition process. The powdered drug is moistened with a suitable amount of menstruum and allowed to stand for 4 hours in a well closed container. Third step is packing. It is nothing but after imbibition, the moistured drug is evenly packed into the percolator. Fourth step is maceration. So after packing, sufficient menstruum is added to the saturated material. Percolator allowed to stand for 24 hours to macerate the drug. The last step is percolation process. The lower tap which is open and liquid collected therein is allowed to drip slowly at a controlled rate until 3/4 volume of the finished product is obtained. So types of percolation. First one is simple percolation. In this, drug which undergo imbibition process for about 4 hours. After imbibition, the sample which undergo maceration process for about 24 hours. Then after maceration, the sample to be undergone percolation process. Then the final products will be collected through the stopper. So this method is, examples for this methods are tincture of belladonna, compound tincture of cardamom. Second method is modified percolation. So in this method, repeated maceration is using. So multiple maceration, solvent divided into equal multiple time considering the solvent retained by plant tissue. This method is used to prepare concentrated preparations. Next one is reserved percolation. In this case, extraction is done through the general percolation procedure. At last, evaporation is done under reduced pressure in equipments like a climbing evaporator to the consistency of a soft extract such that all the water is removed. This is then dissolved in reserved portion which is strongly alcoholic and easily dissolve the evaporated portion with any risk of precipitation. So there are some merits and demerits for this percolation process. Merits are which requires less time than maceration and extraction of thermolabile constituents can be possible through this percolation process. Demerits, it requires more time than soxylation, more solvent is required and skilled person is required for this process. Another method which is used to extract plant constituents is soxylation. This is soxylate apparatus which consists of a heating mantle, distillation flask, siphon tube, thimble, side tube and a condenser. Soxylate extraction is nothing but a continuous extraction process from a solid mixture. Boiling solvent vapors rise up through the larger side arm. Condensed drop of solvent fall into the porous cup, dissolving out the desired component from a solid mixture. When the smaller side arms fills to overflowing, it initiates a siphoning action. The solvent containing the dissolved component is siphoned into the boiler below residual solvent, then drains out of the porous cup as fresh solvent drops out to fall into the porous cup, and this cycle will continue and extraction process will repeat. Supercritical fluid extraction. Actually, for every substance, there is a critical temperature and critical pressure. Above the particular range, it forces the substance into its liquid phase. If the temperature and pressure of a substance higher than that of critical temperature and critical pressure, the substance is known as supercritical fluid. There are some properties for supercritical fluid. At the critical point, density of the gas and liquid phases is same. There is no distinction between the phases, that is between those of the pure liquid and gas. And supercritical possess density that are liquid-like, transport properties that are gas-like. Moreover, this offers good penetrative ability and good extractive ability. This is the process of supercritical fluid extraction, in which the phytoconstituents which is going to separate it from the crude drug is added with the supercritical fluid, and the volatile compounds which are present inside that crude drug will dissolve into the supercritical fluid. Solute and the supercritical fluid leave extracted, and extract become precipitated in separators. And after that, supercritical fluid become changed as gaseous form. Then the gas is recycled by condensation process before it returning to its liquid reservoir. Countercurrent extraction. It is nothing but the liquid-liquid extraction process in which the solvent and the process stream in contact with each other flow in opposite direction. Screw extractors and carousel extractors are the two types of equipments which is used for countercurrent extraction. Countercurrent extraction process. So, for the countercurrent extraction process, wet raw material is pulverized using toothed disc disintegrators to produce fine slurry. Then the material to be extracted is moved in one direction within a cylindrical extractor where it comes in contact with the extraction solvent. The further the starting material moves and the more concentrated extract becomes, finally sufficiently concentrated extract comes out one end of the extractor while the myrrh falls out from the other end. Another method is ultrasonication assisted extraction. This is a procedure which involves the use of ultrasound waves which have frequencies higher than 20 kHz, have great effect on extraction yield and kinetics. This method, which involves ultrasonic effects of acoustic cavitations, under ultrasonic action, solid and liquid particles are vibrated and accelerated. Because of that, solute quickly diffuse out from solid phase to solvent. These extractors are ultrasonic bath or closed extractors fitted with an ultrasonic horn transducer. The mechanical effects of ultrasound induce a greater penetration of solvent into cellular materials and improve mass transfer.